The most common solar cell being used today is silicon solar cell. Theoretically, the energy conversion efficiency is 29%. Also, the usage is strongly affected by temperature fluctuations and weather conditions. Many researches are being made to find a good alternative for silicon solar cells. Now, we will introduce 5 new solar cell technologies that are not based on silicon, from low to high efficiency achieved by now.
PCBM is highly soluble in organic solvents. PCM-based polymer solar cell as a donor can blend ICBA as an acceptor with 1:1 weight ratio after pre-thermal annealing at 150 degrees for 10 minutes to provide temporary highest polymer solar cell conversion efficiency of 6.48%. The good repeatability of PCBM-based polymer offers a great opportunity for the commercial using in the future.
The efficiency of dye-sensitized solar cell is around 11% based on today's technology. A transparent electrode is coated with a porous or nanocrystalline layer of a semiconductor, typically titanium dioxide. The surface of the titanium dioxide is covered with a light harvesting dye. The dye is first excited by absorbing a photon and then produce an electron which goes into the porous titanium dioxide layer. The electron flows to the external circuit through conductive and transparent electrode. Then the electron flows back to the counter-electrode after generating power. Oxidized dyes are then reduced to its neutral state by reduction of electrolyte.
The theory of quantum dot sensitized solar cells is similar to the DSSCs. A quantum dot layer is attached to titanium dioxide to sensitize its absorption. The quantum dots have different band gaps depending on their sizes, so attaching quantum dots to the solar cells creates many narrow bands between the semiconductor band gap. Photons with lower energy still have a chance to excite and build up carriers. Theoretically, it can improve the efficiency to over 80%, but best record so far is merely 9%.
Perovskite, a material that is dramatically cheaper to obtain and use than silicon. Perovskite solar cells so far convert 15 to 20% of the energy in sunlight into electricity. Researchers developing the technology say that it could lead to solar panels that cost just 7 to 14 pence per watt. Solar panels now typically cost about 50 pence per watt and fossil fuel 34. Henry Smith from Oxford University is working to commercialize the technology through a startup called Oxford Photovoltaics, which has raised over $4 million.
The efficiency of best CIS solar cell is about 20%. It is a solid solution of copper indium selenide and copper indium gallium selenide. This material has a band gap range of 1 to 1.7 because of the combination of two alloys. The structure of CIGS solar cell is a substrate, then adding different layers. CIGS has wide spectral response, strong spectral absorption. 99% light is absorbed within first micro of CIGS layer. All these points lead it to be thin film solar cell. By choosing flexible substrate, such as polymers, the cell can be flexible.
In this review, we focus on the efficiency, operation, and characterization of various solar cells that are not based on silicon. Due to the difficulty of the silicon purification, the cost of raw materials is high. Organic DSSCs, quantum dots, perovskite, and copper-based solar cells are introduced since these techniques improve the sustainability and reduce the cost to a large extent.